Hi, I'm Chris Thomas, a Program Manager for the City Waters team at Tauranga City Council. My role is to deliver capital projects, in particular upgrade works at the Maunga wastewater treatment plant. All of the city's treated wastewater is discharged to sea via an ocean outfall pipeline that extends 1 kilometre offshore. This is a critical asset for the city. Like every good story, there is a beginning. And this was the construction of the Outfall pipeline in the late 1970s. During construction, the pipeline was damaged and required substantial repairs. These repairs were carried out using steel bands at significant cracks in the pipeline and grout at other lesser cracks and defective joints. After a failure in the Outfall pipeline in 2012, the operational capacity was derated to 500 litres per second. However, rapid growth in the city will require an increased flow rate of 800 litres per second by the end of the decade. During 2020, the city commenced with the assessment of the internal condition of the pipeline, but was unable to complete this due to the presence of an accumulation of debris at 2 points in the pipeline. It was suspected that the debris consisted of loose pieces of grout that had moved down the pipeline and jammed in place and piled one on top of each other. The city needed to find a way to remove the grout such that the pipeline was not damaged and the flows down the pipeline were not disrupted for more than 3 days at a time. Bay Dynamics entered the story in January 2022 and partnered with the city to develop a remotely operated vehicle that could enter the pipeline, remove the debris, and also carry out an internal inspection of the pipeline using CCTV and sonar equipment.
My name is Matthew Mooney and I am the founder and director of Bay Dynamics. We are an underwater robotics company based in Tauranga. We were approached by the Tauranga City Council to help them solve a unique problem they had with their Te Maunga outfall pipe. Previous attempts to inspect the pipe had not been too successful, and we were approached to create a solution for them to unblock their pipe. When Bay Dynamics was first approached by the Tauranga City Council to take on this challenge, we were already in possession of our own long-range tunnel inspection RV of our own design. However, whilst we had great success using that system nationwide for hydroelectric power companies, it was unfortunately too big to fit inside the Te Maunga outfall pipe. So we took on the challenge of designing a system specifically for this pipe. Due to the unique challenges of this system, Bay Dynamics decided it needed a unique name, and we chose Bidsu Kloakina, which is the Bay Dynamics Service Unit Kloakina, and Kloakina is the Roman goddess who was responsible for looking after Rome's sewer and pipeline system, which we thought was an appropriate name given that we are looking after the Tauranga City Council's outfall pipe. Bay Dynamics created a machine that was capable of unblocking the outfall pipe and to account for large concrete grout pieces that had been identified in the pipe to date, but also to then conduct an in-depth visual inspection as well as a 3D sonar scan or potential laser scan as part of the in-depth inspection. There were many unique features on this machine specifically for this pipe and for this job, and the machine was also designed to account for a number of different objectives, a number of different roles. Currently on the machine is fitted the payload for the 360 sonar scan. This entire front section in this payload bay, which we called it, can be changed out for multiple payloads. Here's another example of a payload here next to it. This is the camera inspection payload, which allows for in-depth 4K inspection up close at any angle within the pipe itself. It also has stereo cameras on board for the pilots to be able to see in different orientations. With a number of lighting options available, the key to any of the designs that we did on this job was modularity, the ability to adapt. It was decided to launch this job from a vessel based at the ocean end of the pipe. The internal diameter of the pipe is 600 millimeters. However, we gave the ROV a cross section of 480 to account for the fact that the pipe, there was no guarantee the pipe itself was in fact straight. Reports had indicated that there was fluctuation in the pitch of the pipe itself over the full length, and so we had to account for that with the ROV. We also made a full cage frame for the system, which meant it was designed to take a hit, it was designed to take a scratch, it can rub up against the pipe and it won't actually damage the ROV. We also allowed for wheels which would adapt to the contour of the pipe itself, and we also allowed for full thrust primarily in the forward back direction. However, the system can pitch and roll in any orientation. It has more than 8 hours duration time running on batteries. However, the system is live fed via a high strength fiber optic cable to surface. All information is in real time and it is piloted from, in this case, from the vessel. There was a lot of unknowns in the pipe. We weren't quite sure what we were going to face, and so we had to account for a worst case scenario. For example, some of the grout pieces that have been recovered to date had only been around 10 to 15 kilograms, whereas we had to account for the fact that some that had not come out were in fact heavier or wedged. So we designed a payload specifically to be able to lift at least 30 kilos, and in actual fact we were able to lift 50, which allowed us to lift it off the invert of the pipe and pull them out one by one. This allowed us to clear the entire pipe over a space of 3 days. Bay Dynamics managed to pull over 120 kilograms of concrete grout from the pipe during the operation, and that allowed the entire pipe to be cleared, free then to be inspected by our inspection payload. We also worked with some local companies in terms of supplies. We were able to get some parts that were required. Wherever possible, we always use local suppliers. Some parts such as subsea housings were supplied via some international suppliers that we work with closely. But in terms of the actual ROV design itself, that was designed, machined, and in some cases 3D printed, all here in-house at Bay Dynamics in Tauranga. During the inspection, we were able to identify more anomalies inside the pipe than had been previously identified. Because of this, it has allowed for the discussions for future work to be done with the same machine, simply by changing out the payloads. As a result of our work on the Maunga Outfall pipe, the debris removal payload was able to remove a little over 120 kilograms of concrete grout from the pipe that had come dislodged and was mobile and or wedged or too heavy to be free moving via the water. As a result of that, the inspection took place with our high resolution 4K camera, which has also got machine vision enhancement to allow us to see through bad visibility. As a result of that, we were able to identify anomalies at many locations in the pipe requiring future remediation. More than 300 joints were all individually inspected, and several dozen anomalies outside of the joints were also identified and inspected in close range. With the current sonar scanning payload, as you see in front of you, the intention here is to create a 3D model of the pipe. It creates a 3D point cloud. This can be textured and meshed and colorized. And the intent is also to do some laser scanning, which creates sub-millimeter accurate models as well for very high resolution modeling. This allows for better decision making by the council to be able to decide how repairs should be conducted in the future and which repairs are more important than others. More intentions down the line is to remove some more of the grout that's still in there. This should be done via a grinding payload for the front, which will allow the pipe to be ground back to its original intended ID, which it was prior to historical repairs. Other intentions are to fill in cracks that may have been identified inside the pipe. This will be done via a high pressure jetter, which will clean organic growth and clean the joints back to bare concrete. We will then go in with a concrete injection payload. This will allow us to fill in these cracks, and then with the other payloads, grind those repairs back to flush for a permanent solution. We also have the ability to inject flexible mortar, which will account for potential joint movement in the future, so that we are not in this particular scenario again, say in another 50 years' time. Bay Dynamics was approached by the Tauranga City Council because we provide a unique offering here at Bay Dynamics, which is to create custom subsea engineering solutions. Council had a problem, and Bay Dynamics was able to solve it by creating a custom ROV to unblock their outfall pipe, as well as inspect in depth, as well as accounting for future repair options, all within the one machine, which will save the council both time, money, and effort, and a significant amount of it into the future.